The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. This is Matt McDevitt with Think Big Analytics. Today we have a featured guest speaker, Jeff Kelly, who is a big data analyst at SiliconANGLE Wikibon, which is based out of Boston, Massachusetts. Jeff is a premier expert from the big data industry and has been following the market for several years. I'll now pass it off to Jeff.
Thank you, Matt, and thanks for having me today. And of course, thanks to everyone tuning in now. We appreciate it. So as Matt said, my name is Jeff Kelly. I'm the lead big data analyst with SiliconANGLE Wikibon. We are a research and analyst firm based in Boston, Massachusetts. We have a media arm in Palo Alto called SiliconANGLE. We focus on a number of enterprise IT topics, but we really base our practice on two, one being software-led infrastructure and the other being big data. So today we are going to talk about the business value of big data, and I just wanted to give a quick overview of what we'll be talking about. So we'll introduce the topic to get our chat started today. And then we'll move on to some common obstacles to big data success and how to overcome them. We'll then move on to best practices for optimizing big data projects. We'll identify big data use cases and tips to do so and how to best deliver business value. And we'll end the conversation with a Q&A where I'm happy to take your questions. Again, just a little information about SiliconANGLE Wikibon. If you have any interest in big data or software-led infrastructure, we are the source to come to. Wikibon.org is where you'll find all of our research. It's open source, meaning it's free to consume, to comment, and even to edit and add your own research. So please do join us on wikibon.org and become part of the community. So let's get started. So there's been a lot of hype and a lot of buzz around big data, perhaps no more buzz around or hype around the so-called 3 Vs. And we've all heard about these 3 Vs and we know what they are: volume, variety, and velocity. Volume refers to, of course, the sheer magnitude, the sheer amount of data that's being created every day. There are figures being thrown around that data is being created in the last several years at a faster pace than it was created in all of human history until then. Needless to say, whatever figure you put on it, we are awash in data today. V for variety, of course, that refers to the structure and the type of the data involved. We're all familiar with structured data developed in our corporate systems, such as ERP systems, accounting systems, etc. But of course, today we're seeing semi-structured data like log file data and other machine-generated data being created at an incredible volume, as well as unstructured data, unstructured text and content that lives in things like social media updates, but also inside the enterprise in terms of content inside of emails and documents and other types of information. And V for velocity, of course, refers to the speed at which this data is being created. And I think just as important, the speed at which enterprises are required to make sense of and take action on that data in order to really maximize its potential. So of course, these 3 Vs are very important, and they underline a lot of the technology innovation that's gone on in this space in recent years. But really the most important V when it comes to the enterprise is the V that stands for value. Ultimately, all the innovation that's gone on in the community in recent years, developing technologies to store, process, and otherwise manage large volumes of data, multi-structured, semi-structured, and unstructured data, all of that innovation really go for naught if it's not put to good use by the enterprise, and that is where the value component comes in. You'll see a lot of different definitions of business value and what it means. Here's our stab at it as it relates to big data. We believe business value of big data lies in the ability to derive meaningful insights from otherwise noisy data, to make impactful decisions based on those insights, and to execute decisive actions that result in increased revenue and profitability, reduction of risk and liability, or improved operational efficiency. Now, I'm sure those of you out there watching and listening now could add some other components to this definition, but we think this is a good working definition to understand really where the value lies in big data. It's not so much the technology that underlies or makes up the infrastructure around big data. It's not even really in the data itself. It's in the ability to derive insights and take action that really impact the bottom line. That's where the value is. And a lot of times in the conversations with big data, that gets lost. And that's not uncommon in a new field or a new area of technology that's developing. There's a lot of excitement around the technology in particular. And sometimes we lose sight of really what the ultimate goal of the technology is. And really, technology is an enabler. And that's the same thing that applies here as well to big data. So, of course, there are some obstacles to big data success that I think everyone should be aware of. I've identified 3 here, and these are certainly not all of the obstacles that stand in the way of big data success in your enterprise, but these are some to be aware of as you get started down this journey. Again, you've obviously joined this webinar here because you're interested in big data. You've heard a lot about it. You've heard some buzz, and perhaps you're interested in really leveraging big data to overhaul your organization. And that's a great place to be, and it's a great way to think. But I think the first obstacle to consider, however, is when organizations get started with big data, they often have grand visions of how they're going to totally remake the organization, the way they do business, the way they operate with customers, the way they deliver their products or services. And all of those types of thoughts are commendable, and in fact, are ultimately the end goal of big data. We do believe it is a transformational technology, not simply an evolutionary step that will only have a small impact. We do believe it is transformational and will impact your entire organization. But as you get started, one of the obstacles is trying to do too much too fast. And as I say here, boil the ocean. That is trying to almost overnight apply big data to all areas of your business, to consider removing or taking out or modifying technology investments that you've made over many, many years, and starting anew with these new style big data technologies. Often when that approach is taken, it can often lead to spectacular failure. And that is really something to be aware of. While big data has the potential to change the way you do business and the way your industry does business, it's not going to happen overnight. And trying to make it so is probably one of the fastest and quickest ways to lead to big data failure. So I would caution organizations to not try to do too much too fast. It's very early days in terms of the technology itself as it's being developed, and there's best practices that are still being developed in a number of areas. So it's important to recognize this as a journey. It's going to take time, and really the journey will never really end. It's all about continually evolving and iterating. So remember not to try to do too much too fast. Another obstacle, as you'll see here on the right-hand side of the slide, as I call it, the elusive data temple. And this relates a little bit to kind of the way we've looked at data management over the years. Most likely in your enterprise, you've got a data warehouse of one type or another. And really the whole idea behind the data warehouse was to develop a single version of the truth. The idea was to use the data warehouse as a central repository to collect data from all of an organization's transactional and operational systems, to model it, to clean it, to process it, store it, and make it available via an enterprise data warehouse for reporting to various business units. In some cases, to do some less than sophisticated but somewhat useful analytics against that data. Think about some of the more recent interactive business intelligence tools that can be applied to an enterprise data warehouse. The problem with this approach, and many organizations have run into this, is that it can take months, sometimes years, to get all of that data from the multiple systems around an organization modeled in such a way that it's ready to be consumed and accessed via an enterprise data warehouse. It's a long, hard slog to do that. And often the results will be a failure in the sense that when results are not seen even in 3 to 6 months, funding and interest in the project can do the project. So likewise, when you're looking at big data, the goal should not be to repeat or emulate this model. The idea of creating a perfect, pristine central repository of data where each data point is in perfect condition is simply not possible. It wasn't possible in the old style of enterprise data warehousing, and it's not possible in the new style of big data. It's just not realistic, and waiting until you get your big data environment into such a state that you would refer to it or consider it a data temple simply is just another way to prolong an unnecessarily long process and ultimately set yourself up for failure. Finally, on this slide, we've got, as I've affectionately called it, fools fall in love. And I use Hadoop as the example on this slide, but it could refer to any other technology. In fact, Hadoop is a very useful technology, but one thing that happens in big data environments or in enterprises that decide to take on big data is they will fall in love with a particular technology, invest in that technology, deploy that technology before identifying any particular business use case for that technology. And this is not a good approach. In fact, we've seen this multiple times in multiple enterprises among early adopters of Hadoop, where they've brought Hadoop in, spun up a cluster, loaded it up with some data, have allowed some of their more sophisticated analysts to take a hack at that data and see what they could find. In some cases, it results in some insights that can be applied to the business processes and the way the organization operates. But in a lot of cases, the time it takes to get that cluster up and running, sometimes with the help of a Hadoop distribution vendor, bring in the expertise and the analysts to do the work on that data, and then realizing that, in fact, we have no particular business problem or way to apply all this data that we brought into our organization is, again, another recipe for failure and the way to lose executive buy-in. So the caution here is not to fall in love with any particular technology and deploy it simply because it's the hot technology of the day. Really, the key, as we'll discuss later in the presentation, to business value is focusing on specific use cases that will deliver value, not simply deploying technology for technology's sake. Again, this could apply to other technologies. It's not exclusive to big data, but it's an important point to consider. I think it might be a little bit more, organizations may be a little bit more risk for this type of obstacle in the big data world because so much of the technology in the big data space is open source, and people sometimes incorrectly consider open source to equal free, and it's not. There's still an investment that needs to be made, both an investment in a financial investment in hardware and in paying staff, but also in time and effort. Hadoop, while it's still maturing rapidly, is still not a trivial thing to operate, and that takes time and effort. And if you don't have a clear business use case in mind, that can be a lot of effort and a lot of money put to waste. So naturally, we come to the next slide, how to avoid some of these common missteps. First off, I think it's important when thinking about big data, while again, it's fine to have grand visions of what big data could potentially do for your organization-wide or even industry-wide. But when it comes to actually getting started, it's very important to focus and to pick small but strategic early projects to get started with. Now, I think this is a critically important point. Often, you may think, a practitioner may think, well, let's start small with something that's, if we fail, it's not that big a deal. I don't agree with that. I think it's important to pick projects that are part of your strategic mission as an organization. So if you are a retail organization, pick a project that's core to your business. And again, we'll talk about this a little bit more in the presentation, later in the presentation, but I think it's important to remember that really big data should be applied to those areas that can directly impact the bottom line and have a strategic impact on your organization. Another thing is more around mindset here on the right hand side of the slide. Big data is messy data, and that's something I think enterprises need to come to terms with. Again, this relates directly to that goal or efforts to create a pristine data temple, where all the data is modeled in such a way that it's very easy to run canned reports against that data. You can almost you essentially know the questions you want to ask beforehand. You model the data to reflect that, and you run your reports. Again, this takes a lot of time, and it's really just not a realistic way to operate in a big data environment, let alone a more traditional data environment. So it's important to understand that big data is messy data. Data sources come from all sorts of areas of your enterprise, and certainly outside of your enterprise. From could be financial data from financial services firms. It could be publicly available data from government agencies, weather data, any number of data types that all come in different forms. And in some cases, the data is not going to be perfectly clean. There are going to be anomalies. But the good news about big data is that at scale, analytics tends to smooth out the I guess you would call it the anomalies in data sets. That is to say, the smaller the sample of data you're analyzing, the higher the anomalies or less than perfect quality data will be amplified. In big data environments, that tends to get smoothed over. So it's important not to get bogged down in trying to make a perfect copy of all your data, and recognize that big data is inherently messy. And part of what the technology and the tools developed in this space are designed to do is to help make sense of that messy or noisy data. It is not the job. It is not a good idea to try to smooth out those anomalies beforehand. That simply will take too long. It won't allow you really to achieve the strategic objectives of your project. The next way to avoid some of these common missteps, again, it's also a mindset, and it applies to a few different areas. And I call it keep an open mind. And it's not simply keep an open mind around the technology, but also the ways you apply the technology. So let's talk about the technology first. As I mentioned, there are more than one occasion that we've seen in recent years where organizations have adopted Hadoop simply because Hadoop was the kind of hot new thing, and they felt like they wanted to be on the cutting edge, only to find they didn't have a business use case, had spent 1 or 2 years investing in hardware and staff to spin up and maintain these clusters, and really at the end not have any way to turn that into business value. So rather than focusing on one particular technology, it's important to keep an open mind around the different types of technology out there. Rather than focusing on whatever may be getting the most buzz, it's important to focus on the end result, the business goal you have associated with the project, and correlate that with the available tools and technologies on the market. So you may be, for instance, this applies to your current infrastructure as well. You may be an Oracle shop, for example, and you may be inclined to go with Oracle hardware and software to begin your big data journey, and that may be appropriate, but it may not. So it's important to not simply go with a particular vendor or a particular technology because that's what we've always done or that's what everyone else is doing. It's important to keep your options open, to explore the market, to see what's out there, and to make sure you pick the right tools for the right job at the time. The good news about this market is that a lot of the tools are open source, and we'll get into this a little bit more, but the fact that the barrier to entry is much lower in terms of the financial commitment that needs to be made when investing in these technologies So that makes your job a little bit easier in this respect. But it's also important beyond the technology to keep an open mind around how you apply that technology to data. Again, big data, we don't believe at Wikibon it is not an evolutionary technology or an evolution of the enterprise data warehouse. It's really a transformational technology, a different approach to using data to improve business outcomes. So with that in mind, it requires practitioners and really the entire enterprise, to rethink the way they do their business processes, to rethink long-held assumptions about the way quote unquote things have always been done, to question long-held assumptions about the way the world is, the way industries operate. Really, there is an opportunity with big data to, as I said at the outset, really transform companies and markets and industries. And it's important to keep that in mind, and not simply use these new style big data technologies to just do what you've always been doing, perhaps at a larger scale or a bit faster than you used to be doing, but to actually keep an open mind and look for new ways and new approaches and completely innovative ways to improve your business, deliver services and products to customers, improve efficiencies, etc. So really keeping an open mind is critical. It's very early days in this market from a technology and best practices perspective. So it's important to keep that in mind and keep an open mind as you move forward on this journey. So how do we optimize big data deployments once we've kind of made the decision to take the plunge into big data? There are a few things here, and some of them really they're really quite simple. The first one is executive buy-in. Again, this isn't necessarily specific to big data. This could apply to other technology areas, but especially when you're trying to adopt a new and in some cases foreign technology, foreign at least to non-technologists. Hadoop and big data have gotten a lot of buzz and hype and press recently. And most of us in the IT community and the enterprise technology community are familiar with it, but some others in the enterprise may not be. So it's important to get executive buy-in very early. Now, to do this, it's important not to focus, when you're talking to C-level executives, on the technology itself. CEOs are not inclined to sign off on new projects simply because you're excited about it or because a technology is new and innovative, and companies like Facebook and Google have used it to great effect. That's not going to sway the more practical CEOs. What is going to potentially sway them is to talk about results, to talk about how big data, when applied to specific business problems, can impact your bottom line. Again, increasing profit, improving efficiency, delivering services quicker, getting to market faster, whatever the case may be. So it's important to get executive buy-in, and to do that by focusing on the business results, the ways big data is going to impact your business, not on the technology itself. Frankly, if you tried to explain to a C-level executive all the components in the Hadoop stack with using terms like Flume and Scoop and Uzi, you would lose them in pretty quickly in that conversation. But if you start to talk to a CEO or other C-level executive about saving millions of dollars by tightening up your supply chain, by getting to market ahead of competitors, by better targeting and delivering personalized service to customers, that's going to get their attention. So focus on the business use case, the business value that you're going to drive from big data, rather than the technology. And again, executive buy-in is important also because there needs to be a mindset in the enterprise that we're going to embrace data-driven decision-making, and that really needs to start at the top. Especially at organizations that in industries that perhaps are not particularly data-driven to this point, where this is a new way of doing business. Without that high-level executive support, even successful pilot or initial projects that show results can stall if the enterprise is not willing to embrace them and and embrace that open mind that I talked about and new ways of doing things. Another important way to optimize big data deployments is to encourage collaboration and communication among the different stakeholders. Doing successful big data analytics and deriving insights and taking action requires a number of skill sets. On one side, you need some technical skills around the new technologies. You need people who are familiar with statistics and analytics, and even further down the stack who understand things like Hadoop and MapReduce. So you've got kind of some of those technical expertise that you need, but you really also need deep business domain knowledge. You really have to understand your business. You really have to understand the business problem and how to apply big data to those problems. Unfortunately, the two skill sets often don't reside in the same person or group of people. So this requires, in many cases, collaboration among different groups of people. It could be IT, as well as data scientists, as well as line of business folks who are maybe less technical. So it's very important to keep the lines of communication open and develop ways to really encourage stakeholders to communicate, to collaborate, to work together, to share ideas. Big data is all about kind of iteration, experimentation, and being willing to fail and try again. So you need to find people that are willing to do that and do that in a collaborative type way. On some level, that's a mindset challenge. You've got to challenge stakeholders to do that. It's also, from a technology perspective, give them the tools in order to do that. The good news is there are tools on the market that have been developed that do allow for that type of collaboration to happen. But ultimately, if there isn't communication, what could happen, and what has happened in some early adopter cases where Hadoop or other big data platforms have been brought in, and some very smart data scientists have been brought in to experiment with that data, they're often kind of put off into a silo of their own. They may come up with some very interesting insights, but they're very rarely applied to the business. They're interesting experiments, but the rest of the organization views them as kind of the mad scientists in the corner doing their work. But I'm going to focus on what we've been doing all along. Really, you need a more integrated approach in order to really optimize big data deployments and projects to really maximize and optimize those projects for success. And another tactic really is to allow, and this is more on the technical side, is to allow those folks that are more technical minded to use the tools and technologies that they're most comfortable with or that they think are necessary to get the job done. This relates to what I mentioned earlier about not falling in love with any one particular technology. In some cases, the best approach is going to be to spin up a Hadoop cluster. But in other cases, a relational style analytic database, columnar MPP analytic database, for instance, might be the proper choice. Another important area here is around the actual tool used to analyze data. In some cases, analysts are very specific about the tools they want to use, be it R or SAS or some other analytic tool set, and it's important to give them the flexibility to do their work with the tools they think are necessary. Again, the good news here is that a lot of the technologies that are being developed in the big data space are of the open source variety. Again, open source doesn't mean free, but it certainly does mean a lower initial financial commitment to use a lot of these tools. Many of the Hadoop distribution vendors, for example, make community editions of their distributions available for free download. Likewise, some of the analytic tools are open source. It can be downloaded for free. And even with some of the services that you need to pay for, there are lower cost options out there, especially when you're just getting started. So again, keep an open mind, look to the tools that will get the job done, and don't just focus on any one particular tool because it's the hot tool of the moment, or it's been getting a lot of buzz lately. But really focus on the tools that will get the job done and deliver the most value. So now I wanted to move on to identifying big data use cases, and this is really important. We've kind of touched on it throughout the presentation, But really, when it gets down to it, you've got to take that first step. You've got to identify that first project and take the leap. In order to do that, a few pieces of advice. One, focus on the core business, and this is related to what I mentioned earlier about focusing on small but strategic projects. If you're, for example, a trucking or shipping company, you want to focus on problems that are core to your business. So that might be something like fuel efficiency or finding the optimal routes for your trucks to improve fuel usage and lower costs. If you are a retailer, it might be, again, something like optimizing your supply chain, something something along the lines of what Walmart's done. We've heard quite a bit about over the years Walmart's use of data. One of the things they've done is really tighten up the supply chain to make it as efficient as possible. Again, in both these examples, these are core to the business at hand, rather than focusing on what could be nagging business problems, but perhaps not as strategic. Maybe they're more administrative. Perhaps big data could be applied to those types of issues at some point. But when you're getting started, it's important to focus on the core business where big data will deliver the most value. Second, tangible results. And what I mean here is focus on problems, initial problems especially, where you can measure outcomes. That is to say, identify problems where you've got metrics so that once you've applied big data to the issue, you can measure it against where you originally stood to show results, whether that's in profit, improved profit, increased efficiency in energy usage or fuel usage, or whatever the case may be. This is important, one, just to provide validity to your project, but also really to what I mentioned earlier about selling to upper management. It's difficult to sell a project that results in kind of fuzzy benefits. When you've got tangible results that you can show on a spreadsheet on the bottom line, we've increased profits, we've reduced waste, whatever the case may be, by this much or that much. That is something that can be leveraged to get further buy-in, to expand big data deployments, big data projects, to expand to other areas of the business. So really focus on those initial problems, initial use cases that when big data is applied to them, will result in tangible results that can be shown to upper management to further executive buy-in. You also want to, when picking your initial use cases, to focus on those use cases where data is available to actually help solve the problem. Oftentimes, organizations up till now, data has been siloed in different departments, and people don't even know what's available within inside the organization. So we think it's important as you're selecting those initial use cases to do a bit of an audit of your data assets. Find out what's available inside the organization. Your organization may have licensed data from third parties, for instance, that you're not even aware of. There may be departments that are collecting data types that you were not aware of that, when applied to your business problem, could really add some significant benefit. So you want to focus on those business problems where data is most accessible and where the right data is accessible when applied, when analytics and big data is applied to it, can actually result in business value. There are, of course, you hear a lot about third-party data from outside the organization, like social media data, for instance, probably is the one talked about the most, and that is important to bring that into the equation in many cases, in many use cases, but not always. So there are, in many cases, the data assets that you require for your big data project, initial project, already available within the organization. It's important to make sure you're aware of what they are and where they are and how to access them. Next, you've got to find the right talent. We touched on this a bit when we talked about collaborating and communicating between groups. But really, it's well known that there is a dearth of analytic talent on the market right now. So when you are identifying your first use cases, you also got to identify the people you're going to involve in the project, those with the skills necessary to manipulate data, to analyze it, to derive the insights. Of course, you want to look in traditional places. You may have, a business analyst team. You may have a business intelligence competency center. You may have those types of folks, and of course, you want to look to them. But I would also recommend looking to line of business units. Often marketing departments, for example, will have one or two people that are just known as being, kind of the statistical wizards at different tools, and maybe that's not well known throughout the organization. So there are more technically inclined people throughout your organization, most likely, that you might not be aware of. So be sure to look throughout the organization for the people with the skills necessary to participate and help bring value to big data projects. And finally, leverage the community and partnerships. One of the great things about the development of this market is that it is largely open source, and that the community that's developed around things like Hadoop and Apache Cassandra and other open source projects is that everyone is very willing and very eager to help one another. There's community events going on throughout the country, whether those are big events focused on particular technologies or local meetups in your city or town. There are a lot of opportunities to meet with the community, to learn from them, learn from others' mistakes and their successes. And I think you'll find, for the most part, that the vast majority of people in the big data community are more than happy to share their insights. So learn from them. There's no reason to reinvent the wheel. Where there are opportunities to get advice on initial projects that worked, that didn't work, strategies and tips for selling to upper management, whatever the case may be, leverage the community and leverage partnerships with like-minded organizations. It's a huge treasure trove of value just right there, and it's very important to tap into that. You can't say this for all technology areas, so it's one of the real benefits of the big data movement. Well, that about wraps up the structured portion of the presentation. I'm happy, of course, to take questions from listeners and viewers. Let me just check now to see if we've got some questions here. All right, and it appears we do have a few. First question, so what verticals do you see big data technology being used most frequently in? Well, some of the early adopters that we're seeing in big data, I think one of the earliest is government, and specifically intelligence agencies have been, certainly in the 9/11 era, have focused on acquiring intelligence through the use of data analytics, tracking so-called bad guys through various means. So that's an early adopter market. Financial services is another. Financial services is often on the leading edge of technology, looking to always find an edge over their competitors in the market. So that's another. Things like, of course, you're probably familiar with high-speed trading and things like that are based on algorithmic programs. So that's one example. Financial services firms are, of course, also heavy users of big data analytics to identify and stop fraud. That's an area that's very important to those types of organizations where billions of dollars is lost every year through fraud. So we see those two industries as early adopters. And of course, when it comes to retail, the big retailers, the national retailers, are very early adopters, using big data and analytics to both target customers with personalized ads and other content to really increase the likelihood that they'll spend with the retailer, as well as using big data and analytics to create and display targeted advertisements online. Think of online retailers and other online companies, web companies that are doing that. So those are three areas, three industries that are really kind of early adopters. But we're starting to see, other industries and other verticals start to pick up. So it's a very interesting time right now. Okay, let's see. We've got another question. So kind of a corollary. So what industries have not been too involved in big data but can benefit from it significantly? Well, There's a few that come to mind, and I think probably the one that comes to mind the most or foremost in my mind is healthcare. We all are familiar with the looming healthcare crisis, or I should say, we're really in a healthcare crisis right now with prices and costs skyrocketing. Healthcare is a huge component and is of our national budget, and is going to only grow proportionally to the rest of the budget uh, as time progresses. So there is a need for sure to apply analytics to improve care, but also make it more efficient to lower costs. I think there's a couple reasons that hasn't happened to the degree we had hoped yet, and one is simply that it's a highly regulated industry for understandable reasons. Privacy is a concern, and that makes it difficult to start bringing together different data sets and analyzing them when you've got different level of compliance and security um, rules that need to be applied. So that's one reason. Another simply is that healthcare tends to be a little bit of a laggard in uh, adoption of IT technology. I think we're going to get there. We're seeing some interesting developments in the market from a technology perspective to address some of the compliance concerns. Um, but that is certainly one area where I think a lot of value could be derived from big data analytics. Another, of course, is education. Another issue that's very important to the country at large. Making the most of our education resources to make sure as many children have the best opportunity to a good education as possible. To identify new ways to teach and new ways to innovative ways that children can learn. So as that's applied to as big data is applied to those problems, there's a lot of value that could be delivered there. Again, education often, unfortunately, underfunded in this country, and that results in some little bit of a lack of, or tend to be a little slower in terms of adopting new cutting edge technology. But again, there's activity in the market, startups as well as big vendors looking to apply big data to education related problems. And as this market matures, the prices will come down and there will be more opportunity, I think, to apply big data to education. So we've got another question. You mentioned that Hadoop is not the only technology out there. So what other major technologies are leading the big data charge? That's a good question. In a lot of cases, people think when they hear big data, they think it equals Hadoop. And as I mentioned earlier, Hadoop is a fantastic new technology. It's really a framework, a set of technologies for processing and storing large volumes of semi-structured data, something we couldn't do before, either because it wasn't financially feasible, would just be too expensive to do it with traditional tools, or simply because those tools couldn't handle the sheer volume and would collapse under the pressure. So Hadoop is very important and a very impressive new technology framework, but there are others. The whole world of NoSQL, meaning not only SQL databases. These are uh, different flavors of NoSQL have developed to focus on different end user, I should say, specific uh, use cases. Things like graph databases. We heard about Facebook releasing their graph search a couple days back. These types of graph databases are focused on understanding social networks or networks of any kind, really. It could be a social network such as Facebook. It could be used in intelligence agencies to better understand terrorist networks. So databases like Neo4j, for example, is a leading graph database that's getting some attention these days. There's another very interesting NoSQL database called Accumulo, which was originally developed at the NSA and is now an open source project. Which really, one of the key benefits of Accumulo is it brings in kind of very granular security controls that some of the other NoSQL databases lack. So that's another interesting technology. A little bit further up, higher up the stack, we're starting to see some big data application development tools emerge. Companies like Continuity are starting to emerge where they're offering basically data fabric layer where developers can leverage the work of data scientists and others to incorporate those analytics into high performance applications for end users. So that's another area that we're interested in and keeping a close eye on. And there's also some of the legacy technology, if you can call it that, companies that are doing kind of new age data visualizations. but were not necessarily developed as part of the big data landscape, specifically talking about Tableau. Doing some very interesting visualization technology that popular among the data scientist set, allows you to do interactive queries to visualize in any number of ways. So these kind of visualization tools are starting to really create some pretty sophisticated capabilities, and we're seeing those applied quite frequently as well to big data use cases. And finally, last question has to do with the cloud. So what value do you see in utilizing the cloud to jumpstart a big data project for initial proof of concept and pilot projects? Do you think that full implementations can be made on the cloud, like something like Amazon Web Services? So the first part of the question, I think the cloud is a very viable area to do certainly test and dev and pilot projects when it comes to big data. It doesn't you're not required to buy your own hardware and knit together your own Hadoop cluster, for example. You can spin one up in Amazon's cloud quite quickly. Of course, there's Google has some of their has recently made available some of their internal tools to outside developers, things like BigQuery. So I think it's certainly a viable area to the cloud is a viable area to do some of those proof of concepts and pilot projects. When it comes to doing putting big data projects into production and really scaling them out to truly big data workloads, that's another question that it remains to be seen. The value, the cost equation changes when you start expanding to such large levels, large deployments in the cloud. It certainly makes sense when you're talking about a small pilot project, but when you're doing something at scale, there are occasions when the economics just don't make sense to do that in the cloud. So that's a question that remains. I think one of the other barriers to cloud-based big data, of course, is just data movement. Getting data from your data center into the cloud or vice versa in large volumes, you're restricted to basically internet pipes. So that is an issue that is yet to be solved. The reality is that in some cases, to this day, the fastest way to get data into Amazon's cloud is to send it on via FedEx on a hard drive. So, that is not a sustainable approach, I don't think. So that'll require new and innovative ways to move data over the public internet. So that remains to be seen, but it's certainly a possibility and something we're keeping a close eye on. Well, that just about does it for today. Wanted to thank everyone for joining us. Again, we very much appreciate it. Sorry, let me just pull up my final slide here so you can see this. There we are. Well, I think you can see it. In any event, Matt, thanks again for having me. I appreciate it. You can see our contact information here. You can reach me anytime, jeff.kelly@wikibon.org, on Twitter @JeffreyFKelly, or visit wikibon.org/bigdata for all of our big data research.
Thanks a lot, Jeff. Really appreciate your time. Also, if you would like to learn more about Think Big Analytics and some of the amazing work that we're doing, basically helping companies make big data come alive, utilizing many of the things that Jeff spoke about earlier, you can contact me. My contact information is right there, matt.mcdevitt@thinkbiganalytics.com, and I can set up a call with you with one of our experienced consultants. Everyone, thank you for attending this webinar. Looking forward to seeing you at our future webinars, and have a great day.